Okay, so today we are going to be looking at arc lengths and area of sectors. Now I'm sure you have done this in geometry, but we're going to be looking at it in both degrees and radians today, now that we've started to use radians. So first thing we'll start out with is arc length. So hopefully we remember diameter is a segment that contains the center of a circle and has endpoints on either side of the circle. We know that the diameter is twice our radius, or our radius is half of a diameter. The central angle is an angle whose vertex is in the center of the circle. So right here, if we were to call this CPA, this would be our central angle. Now, an arc, right, is a portion of the circumference of the circle. So the circumference is basically another way of thinking of the perimeter, but of a circle. So here, if we want an arc, we just want this portion of the perimeter, right? I don't want the entire circumference. I just want the portion of this arc. So circumference, if we remember, is pi times the diameter, or 2 pi times our radius. So because we are just looking at the arc length, I'm going to be multiplying that by that portion of the circle. So I know a full circle is 360 degrees. So if my angle was, say, 60 degrees, I would want to do 60 over 360, or 1/6. So I'm trying to find the arc length that is 1/6 of my circle. So in order to do that, the equation we're looking for, right, is our angle divided by 360 times 2 pi r. So let's say this was 60 degrees, and let's say we had a radius of 4. I could treat this with our equation. It would be 60 over 360 times 2 pi times our radius of 4. So I already know 60 over 360. I can simplify that to be 1/6. Times, I know 4 times 2 is 8, so times 8 pi. I can simplify that to be about 4 pi over 3. Now, I did not give you any units. Make sure that if there are units, we're attaching those. So here, if I'm looking for arc length as a radian, I see here that it just has S equals R theta. So theta, this is the Greek letter theta. It's just another variable. All it means is it's representing the angle. So this equation here is telling me that the arc length is going to be our radius times that central angle. And you might be saying, hey, hold on, right? Just up here, we had our angle divided by 360 times 2 pi r. So shouldn't we have to do the same thing? Right, so I know 360 degrees is 2 pi radians. So I'm going to sort of translate this equation to be in radians. So I'm going to say my angle, right, my angle, and instead of 360, I'm going to do 2 pi, because 2 pi radians, remember, we're in radians, right? 2 pi is equal to 360. And then I'm going to multiply that times my 2 pi r. Now looking here very clearly, I can see that I can cancel these 2 pi's. And when I do that, I'm left with my angle times my radius. So that's where this equation came from, right? It basically is a simplified version of this equation right here. And if we wanted to use that same equation in terms of degrees, right? So I still have my radius times my angle. And then I just have that times pi over 180, which if we remember, right, that's how we convert between degrees and radians, right, is that pi over 180. So that's where that's coming from. However, we can still use the same equation that we started with. If we were to use that same angle over 360 times 2 pi r, the only real difference between this equation and this equation is that they simplified the 2 and the 360. So notice that even though this is a totally different way of thinking, it ends up being the exact same math. So either one of these equations is going to work. It's going to give you these same values. So if we use that for this problem, I want to find the perimeter of this slice of pizza. I know that it's a 60-degree angle and it has a 7-inch radius. So if I'm finding the perimeter, I know that's going to be my 2 radii plus this arc length. All right, so I got to find what that arc length is so that I can add it back to my perimeter. So again, you can use either version of that equation, right? But if we stick with the original one, if that's typically what makes the most sense for you, we stick with that one. That's going to be our 60 over 360 times 2 pi r. That'll simplify. You can simplify that to 60 over 180 times pi times 7. So two different ways to think about it. It's going to give us the same numbers. We can simplify this. 60 over 180 is the same thing as 1/3. So this is really 1/3 times 7 pi, or 7 pi over 3. Inches, since I did give inches. So if I'm just finding the arc length, I got that it was 7 pi over 3. I personally am going to ask you to keep your answers in terms of radians, so you do not need to tell me the decimal. In this problem where I'm looking for perimeter, decimal is probably more appropriate. However, in some of these problems, we're going to look to just keep it in terms of radians. So to find the perimeter, I would plug that back in, add those together, and get my answer. Second thing we are going to be looking at is area of a circle. So hopefully we remember that is pi r squared. Now if I want the area of a sector, again I only want a section of that circle. Same way we did with that arc length, we're going to multiply that area times that proportion of the circle. So depending on what that angle is, that's what we are going to do, either divided by 360 or divided by 2 pi, depending on whether or not we're working with degrees or radians. So an example of that, if I look over here at number 10, I see I have 30 degrees and a 12-inch radius. So if I plug that in, my equation will look like this, right? My 30 degrees out of 360 times pi times my radius squared, which is 12 squared. I know that's equal to 144. And I know that 30 over 360, I can simplify that to be 112. Which I can then simplify this whole thing to be 12 pi inches squared. Again, we can't forget our units, and we want to make sure that we are leaving these in terms of pi. So I'm going to skip over to number 12. Number 12, we need to be careful, right? Because I gave you a diameter here of 16. But in our equation, right, we use our radius. So we want to make sure that we're remembering that our radius is equal to 8. So when I plug that into my equation, again, I'm trying to find the area of the shaded sector. So not 45 degrees, but rather 315. And I know that 315 over 360, I'm able to simplify that to be 7/8, right? And 8 squared is 64, which we can then simplify to 56 pi centimeters squared. Again, because it's area, our units are going to be squared. So last thing we will look at is we can also look at area of a sector in radians, so using that radian measure. So what this math here is telling you is basically that the ratio of the area of a sector of the circle to the area of the whole circle is the same thing as the ratio of the arc length to that circumference. So basically it's saying those ratios are the same thing, and from there we're able to simplify and get this equation. Another way we can think about it is the same way we just did up here with degrees, except now think about it in terms of radians. So we'll have our angle over 2 pi times pi r squared, and here you can clearly see I can cancel these pi's, and I'm left with my angle times my radius squared divided by 2, or 1/2 my angle times radius squared, which, right, is the equation we have over here. So again, it's all the same thing, we're just simplifying. So both of these, it's the exact same math, just simplifying. So here, if I'm looking for the area of a sector and I give you radians, these are sort of the three different ways that you can find that area, right? So we have that original equation with our angle divided by 2 pi times pi r squared times our area, right? Or we have this equation but simplified right here, so the exact same math, just simplified. Or third option, we can convert to degrees, right? And that plug that in and solve. But again, all of this, the same math. We're going to get the same answer. So to solve this equation right here, I'm going to quickly just do this first method. But again, any of these three methods will get you the right answer. So I'm going to start by plugging in my angle of 2 pi over 5 and my radius of 4.5 centimeters. Now from here, once I plug that in, I simplified to about here, so I can either leave my answer as 20.25 pi over 5, or a little bit of a sneaky way, right? I know that 0.25 is 1/4, so I can rewrite this as 81 over 4, which then when I multiply it times pi over 5 gives me 81 pi over 20, and then our units, centimeters squared. Or we can plug into our calculator, we get a decimal of about 12.723 centimeters squared. So again, I'll typically ask you to leave it in terms of pi, but any of these answers are correct. They are all the same thing, just in different forms. And again, either of these three methods should have gotten you the same answer. If you have any questions, please let me know. Otherwise, hopefully this was a good review of arc length and sector area.